Okay, we're on 5.1 right now. We're talking about reference numbers. So let's define what a reference number is. Let t be a real number. The reference number t bar associated with t is simply just the shortest distance along the unit circle between the terminal point determined by t and the x-axis. Let's take a look at 4 examples here to take a look at that and see exactly what that means. Suppose I have a unit circle and I've got some distance t wrapped around starting at the point 1, 0, this point 1, 0, wrapped around the unit circle in a counterclockwise fashion, okay? Well, this is my terminal point. The reference number is the shortest distance along the unit circle between the terminal point and the x-axis. So we're talking about what's the shortest distance from here, that terminal point, to here, okay, the x-axis, along the unit circle. Well, it turns out that t and t bar are the same number. The reference number t bar are the same number. That is the shortest distance from here to here along this unit circle. Okay. That was a trivial example. Let's take a look at the second example here. Suppose I have my terminal point determined by the length of t, where I start at the point 1, 0, and I end here in quadrant 3. Okay. Well, here's my terminal point. What's the shortest distance from this point to the x-axis along this unit circle? Notice you don't go straight there. You got to go along the unit circle. Is it this way? Is it that way? Of course, it's this way, right? To get to this x-axis along this distance right here, right there, is considered t bar. Okay, that distance. Okay. Let's go to the next one. What's the shortest distance from the terminal point to the x-axis along the unit circle? Well, it's this distance. And that distance we're calling t bar. What's the shortest distance from the terminal point to the unit circle, or to the x-axis along the unit circle? Again, it's this distance, which is t bar. So what we're determining here is just reference numbers. Now what we're going to do is we're going to use reference numbers later on. Right now we're just kind of getting used to exactly what reference numbers are. Okay, so now what we're going to do is we're going to find the reference number for each value of t here. So I've got 3 different values of t, and what's the reference number associated with them, okay? So the way we do that is we first, sometimes this helps is draw a small little unit circle to understand what's going on. Okay, I've got a small little unit circle. I'm going to draw my value of t. My value of t is 5 pi over 6. 5 pi over 6 puts me here in quadrant 2, right there. That's the value of t. Therefore, what's the shortest distance from the terminal point determined by this value of t and the x-axis? Well, that's this distance here. And that value is t bar. Okay? Fine. What is t bar? Well, if it's 5 pi over 6 to here, and a total of pi from the point 1, 0 to the point negative 1, 0, then we know that t bar must be pi over 6. 5 pi over 6, pi over 6. Okay? Let's do another one. Suppose I have 7 pi over 4. Again, I'm going to draw a small little unit circle. Where's 7 pi over 4 land? Well, 7 pi over 4 lands from here. Puts me over to this quadrant right here. Again, you can count by pi over 4s. 1, 2, 3, 4, 5, 6, 7, right? 7 pi over 4. Okay, that's the terminal point determined by this value of t. Okay, therefore, what is my value of t bar? Well, what is t bar? T bar is the shortest distance from the terminal point to the x-axis, turns along the unit circle. Turns out as this distance here. That turns out to be pi over 4, doesn't it? Okay, so we're understanding how to find reference numbers given a value of t. Now I have t equals negative 2 pi over 3. Draw my unit circle, fantastic. Negative 2 pi over 3, so now we're going to move in a clockwise fashion to find t. T is negative 2 pi over 3, puts me here, right? T equals negative 2 pi over 3. Okay, so what's the shortest distance from the terminal point to the x-axis? Well, it's this distance right here. That's 2 pi over negative 2 pi over 3. This distance right here would be t bar equals pi over 3, that distance there. Okay. All right, so we found reference numbers for each value of t. Okay, so now what we're going to do is we're going to use the reference numbers to find the terminal points. The first thing we want to do is we want to find the reference number t bar, okay? After we find the reference number t bar, we're going to find the terminal point determined by that t bar. Okay, after we do that, the terminal point determined by t is simply the point p plus or minus a, plus or minus b, where the signs are chosen according to the quadrant in which the terminal point lies. Okay, so let's take a look at a couple examples. So here I have find the terminal point determined by t. I got t equals 5 pi over 6. Where's 5 pi over 6? 5 pi over 6, we're into quadrant 2 here. This is t equals 5 pi over 6. We know then that t bar is the shortest distance from the terminal point to the x-axis. That's going to be t equals pi over 6. Okay? So, what's the terminal point determined by t bar? Well, we know we've memorized our unit circle in such a way that we know the special values here, 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 and here. The terminal points according to t equals 0, t equals pi over 6, t equals pi over 4, and t equals pi over 3, and t equals pi over 2. These are very easy to remember. So if we know the value of this terminal point, which is square root of 3 over 2 comma 1/2, we know that this terminal point will be plus or minus depending on what quadrant it's in. Well, this is in quadrant 2, so we know that the x value is going to be negative. So it'll be negative square root of 3 over 2, comma, it's a positive y value, positive 1/2. So that gives us the terminal point as determined by t equals 5 pi over 6. Okay? So really, you only have to memorize these ones, and we get all the rest of them. Okay? So I've got a little bit tougher one here. Okay? 29 pi over 6. Oh, good lord. 29 pi over 6. Well, there's a lot of ways to do this. The key is, where do we find out this thing ends? Well, here's one way to do it. You can break this down and say, you know what? This is the same thing as 24 pi over 6 plus 5 pi over 6. Right? 24 and 25 make 29. Now, why am I doing that? How many times does 6 go to 24? It goes 4 times, right? And isn't that the same thing as 12 pi over 6 plus 12 pi over 6 plus 5 pi over 6? Why am I doing this? Well, what's 12 pi over 6? 2 pi. 12 pi over 6, 2 pi. So if I'm wrapping this around, I go, to find where t lies, I go 2 pi, 12 pi over 6, boom, 2 pi, good, and then 5 pi over 6, which gives me a terminal point there, okay? So this is t equals 29 pi over 6, therefore again, the same type of problem. This distance is t bar. Well, what's t bar equal? Pi over 6. We know that the terminal point as determined by pi over 6 has the coordinates root 3 over 2, comma 1/2. Therefore, this one in quadrant 2 will have negative root 3 over 2, comma positive 1/2. Sound good?